Now velocity gradient, we will discuss coefficient of viscosity in this topic. So it is velocity gradient and coefficient of viscosity. So velocity gradient I have already told you, I might have told you in the chapter work power energy. Let me explain it again. Gradient means any change with respect to distance. Any change with respect to distance. Say for example, there is temperature gradient. Change in temperature with respect to distance. That is, change in temperature upon change in distance is temperature gradient. Velocity gradient is change in velocity with respect to distance. Say for example, a liquid is flowing and at the top it has a velocity v plus dv, and below that there is a layer which has a velocity of flow as v. Between these two layers the distance is dx. So there is a change in velocity between the two layers with respect to distance. This is known as velocity gradient. Same is potential gradient. Change in potential with respect to distance. So here velocity gradient is the ratio of change in velocity to change in distance. Because it is velocity gradient, it is change in velocity to change in distance. If it is temperature gradient, change in temperature to change in distance. So velocity gradient is change in velocity is dv upon dx. So this is velocity gradient. Its dimension Lt minus 1 upon L, that is T minus 1, which is similar to frequency. So its dimension is similar to frequency, and unit will be, what will be the unit? Per second. It is a vector quantity. Vector quantity normal to the flow of fluid. Normal means perpendicular. Normal to flow of fluid in direction of increasing velocity. In direction of increasing velocity. So here the direction will be, this is the velocity gradient. This is a new term, velocity gradient. So be careful about this. Velocity gradient. And now coefficient of viscosity. So according to Newton, here again Newton explained it. According to Newton, viscous force depends on two factors. First is viscous force is directly proportional to velocity gradient. Is directly proportional to velocity gradient. And second one is viscous force is directly proportional to area of contact. Area of contact between layers of flowing fluid. So be careful. In solids there is friction which never depends on area of contact, but in liquid viscous force depends on area of contact. Now combining these two, viscous force is given as velocity gradient into area. Now removing the proportionality constant, you are going to get a constant this is viscous force, where this proportionality constant eta is known as coefficient of viscosity, where eta is known as coefficient of viscosity, which remains constant for a particular fluid. So here, if you want to find the dimension of coefficient of viscosity, it becomes F upon A dV by dx. Now, finding its dimension of eta is, force is ml t minus 2, you all know. Area is L square, and I have already given you dimension of velocity gradient, so it is t minus 1. So on solving this, you are going to get ml minus 1 t minus 3, sorry, t minus 1, ml minus 1 t minus 1 is the dimension of coefficient of viscosity. Its unit of coefficient of viscosity is, you can get it from the dimension also, it is kilogram per meter second. Kilogram per meter second is the dimension, is the unit of coefficient of viscosity. It is also termed as, this is also termed as poise or Poiseuille. Poiseuille is denoted by P into Pi. So it is, in short, it is also given as poise. Unit of SI unit is, this is SI unit is kilogram per meter second, It is also known as Poiseuille. So SI unit is Poiseuille, PI. CGS unit is gram centimeter second, which is known as poise. So 1 Poiseuille is equals to 10 poise. This is the relation between SI and CGS unit of coefficient of viscosity. Now, how will you define coefficient of viscosity? So here, if A is 1 in this formula and dV by dx, velocity gradient, is also 1, then coefficient of viscosity is equals to force, viscous force. So coefficient of viscosity can be defined as numerically defined as the viscous force coefficient of viscosity is the viscous force between layers of unit area and unit velocity gradient. So this is about coefficient of viscosity. Now I am giving you 2 questions for Google form. Question number 1. Question number 1 is, write the Reynolds number for streamline flow. Reynolds number for streamline flow, that is maximum. This is for Google form, answer number 1. Question number 2 for the Google form. For the Google form, question number 2 is, define critical velocity. This is your answer number 2 for the Google form. Submit your answer to mark your attendance. And in the next class, we will continue with the factors and Stokes law. Thank you all.